Hello everyone, this is Hating Tian. This video we are learning chapter 5.5 double angle identities. The angled identities are here in the table, so please spend some time here to memorize all of these five identities. And the double angle identities can be derived from the following. So for example, if you do not remember how to find double angle identities, we can find them from this. For example, if I have the sine 2a, then I know that sine 2a means sine a plus a. What is the sum of the sine? The identity is sine a plus a is sine a times cosine of second angle, which is the a, plus cosine a times sine a. Oh, they are the same because sine a times cosine a equals cosine a sine a. So this is 2 sine a cosine a. So this is the identity here. And how about cosine? So if I have the cosine 2a, this is a cosine a plus a. Oh, I am always saying b. This is cosine a squared. Oh, sorry. Stop. Slow down. Cosine a times cosine another angle a minus sine a times sine of second angle a. So you see this is cosine a squared minus sine a squared. This is the identity here. And how about the identity here and here? So we have learned the sine a squared plus cosine a squared equals 1. So in the identity here, we have cosine a sine a. How about replace this sine a with a cosine a? So how about isolate this one and then minus cosine a squared both sides. Then I have sine a squared equals 1 minus cosine a squared. And then plug this one into the equation here. I'm having another identity, which is cosine a squared minus 1 minus cosine a squared. Then I'm having 2 times cosine a squared minus 1. This is my second identities here. So this is my identities here. And then if you want to replace the cosine by the sine, so use this identity, Pythagorean identity again, you will find that equals 1 minus 2 times sine a squared. So please spend some time to memorize the identities here. And how about the tangent 2a, the last identity here? If you have your formula here, tangent 2a. Tangent 2a equals tangent a plus a. This is on the top of the tangent, we have tangent a plus tangent a divided by 1 minus tangent a times tangent a. This is 2 tangent a over 1 minus tangent a squared. So that is the formula here. All right, let's see the first example. Find cosine 120 degrees by using double angle identities. So we are not using the method that to find the reference angle of 120, 60, and then this one equals cosine 60, but negative because cosine in the second quadrant is negative. We are not using this method. We are using a double angle formula or double angle identity. We know that cosine 120, so focus on the 120, is 2 times 60 degrees. So 2 times an angle. So I can use double angle identities. Maybe I pick one because for the cosine 2a, so you see cosine 2a, I have 3 formulas. So I can pick any one of them to find my value of cosine 120 degrees. So if I'm using the first one, so that is cosine 60 squared, 60 degrees squared minus sine 60 degrees squared. And then I know these are special values. So cosine 60, that is 1/2 squared minus, what is sine 60? It's square root of 3/2. This is 1/4 minus 3/4. This is 1 minus 3/4 is negative 2/4 is negative 1/2. Okay, so cosine 20 is negative 1/2. All right, let's see next example. Find the value of the sine and cosine function for each angle measure. So we're looking for sine 2 theta, and given that sine theta equals 2/5 and cosine theta is a negative number. So how to find the sine 2 theta? We have the formula of sine 2 theta, which is 2 times sine theta times cosine theta. So in this formula, sine theta is given. I need to find cosine theta. How to find cosine theta if the sine is given? So we can assume that sine theta equals 2/5 is y/r. And we're looking for the value of the x. So x is positive or negative? I don't know. But here is given cosine theta is negative. If cosine negative and sine is positive, where is my theta? So for the sine theta positive, ASTC, sine positive in these two quadrants, quadrant 1 and 2, and cosine negative is in these two quadrants, quadrant 2 and 3. So I checked 2 times in the quadrant 2, satisfied 2 conditions. So theta is in the quadrant 2. So in quadrant 2, x is negative. So it's negative square root of r squared minus y squared. Here, from this step, I assume that y equals 2, 5 equals r. So negative square root of 5 squared minus 2 squared is negative square root of 25 minus 4, 21. And then what is cosine theta? Cosine theta is x/r. It is negative square root of 21/5. And the formula sine 2 theta equals 2 times sine theta times cosine theta. And we have 2 times. So sine theta is given is 2/5. And cosine theta is negative square root of 21/5. And let's do the simplification. We have negative solution. The bottom multiplied by the bottom 25. And tops multiplied by the top. So it's 4 times square root of 21. So this is a solution. All right, let's see next example. So if we are looking for the cosine 2x, given the tangent x equals 2, how to find cosine 2x? We have 3 formulas, right? What are the formulas of cosine 2x? So we have cosine x squared minus sine x squared, and also we have equals. So we have 1 minus 2 times sine x squared, and also we have 2 cosine x squared minus 1. So we got these 3 formulas, but none of them have the given information tangent x. How to do that? We have learned that. We can find the x, y, and r's value, and then find the sine cosine value, right? So now what is x, what is r? Remember here, this x is the angle theta, angle. So do not confuse yourself. This is the For example, tangent to theta equals y over x. Do not confuse this x with the x here. They're different. The x here is a ratio, is a value. The bottom of the ratio is a value. It is not the angle. So this is a little bit confusing because they use the x. So most of the time I'll give you the theta or alpha or beta or gamma. So I will not choose the x, but you still know that. For example, so maybe I use different color for the x. I use the red color for the red x. So this x is the angle x I'm looking for. But later I use different color. That x is the x of the point on the terminal side of the angle theta. Okay, so let's see. Tangent x equals 2. Can you convert the 2 to be a fraction? 2 over 1. And this one for the tangent equals y over x. So this x and red x are different. I can assume that y equals 2, x equals 1. Can you find r? Yes. And can I say both of the x and y, they are positive? It's hard to say because I don't know the y and x, they are positive or not. I want to see maybe from the previous step, I need to see where is x? Where is the x in the given information that tangent is positive? Tangent positive equals 2 must be in the first quadrant and third quadrant. And the given information is cosine x is positive. Cosine positive is in the first quadrant and last fourth quadrant. That means the, sorry. So that means my x, my angle red x is in the first quadrant. Oh, in the first quadrant, in the Q1 first quadrant. So the x, y both positive. That's the reason I have positive x and positive y. How about r's value? R equals x squared plus y squared. So that is 2 squared plus 1 squared is 5. So r equals square root of 5. And how about find maybe find cosine x. So cosine x is in the first quadrant, and the cosine equals x over r. And what is the x? X equals 1. R is square root of 5. And if I'm looking for the cosine 2 theta, let's choose this formula. So I'm having a cosine 2 times x equals 2 times cosine x squared minus 1. And then we have 2 times 1 over square root of 5, all of them squared minus 1. Remember that cosine x squared, it is cosine x squared. Okay, so let's simplify the expression. We have 2 times 1 over 5 because you need to have you square the top and square the bottom. Minus 1, we have 2 over 5 minus 1. We have 2 over 5 minus 5 over 5 is negative 3 over 5. So we are having negative 3 over 5. Okay, or I box the solution. Okay, let's see next example. So given that sine theta equals negative square root of 5 over 7 and cosine theta is positive, say positive value, and looking for the cosine 2 theta. Okay, so do I need to find the cosine's value, or do I need to find the other informations because I have learned that we have three formulas for cosine 2 theta. What are they? We have the sine cosine 1 and sine squared only 1 and the cosine squared only 1. If the given information is sine theta, so that means I can choose the formula has the theta only. Have the sine theta only. That is 1 minus 2 times sine theta squared. So I don't need to use the cosine because even if the information is given, but my formula doesn't have the cosine part. So we can only use the formula here without looking at other information, less steps. So cosine 2 theta equals 1 minus 2 times sine theta squared. And then put the information in it. We have 2 times negative square root of 5 over 7, all of them squared. It's 1 minus times 49 squared the bottom, squared the top. We have 1 minus 10 over 49. We have 49 over 49 minus 10 over 49. So this is 39 over 49. So this is a solution. Okay, let's see next one. The given information is cosine 2 theta equals 3 over 5. And the theta in the quadrant 1, find the sine theta. So first from the given information, theta in quadrant 1, that means sine theta is positive, is greater than 0. And how to find sine theta? The given information is cosine 2 theta. What is the relationship between cosine 2 theta and sine theta? We just learned the formula today. That is cosine 2 theta equals 1 minus 1 minus 2 times sine theta squared. Oh, we got sine theta part. We got sine 2 theta part. Okay, we can isolate the sine theta, right? Okay, so let me erase the color, or we stay it like this. So let's isolate the sine theta. I can move the negative 2 sine theta squared to the left hand side. I can add 2 sine theta squared both sides. Isolate it. So we have 2 sine theta squared plus cosine 2 theta equals 1, and subtract the cosine 2 theta both sides. Oh, sorry, cosine 2 theta. So 2 sine theta squared equals 1 minus cosine 2 theta, and divided by 2 both sides. So sine theta squared equals 1 minus cosine 2 theta over 2. And isolate the sine theta, can square root of both sides. 1 minus, in the square root, we have 1 minus cosine theta, all of them divided by 2. I need to decide if it is positive or negative. The given information says theta in the first quadrant positive. That means I only need to keep the positive sign. 1 minus cosine theta over 2. I missed some information. Do not copy the wrong things. This is 2. Do not lose your 2. So let's plug in the information. What is cosine 2 theta? It's 3/5. 1 minus 3/5 over 2. So I'm having square root of, on the top is 2 over 5 over 2. And then do the simplification. I have 1 square root of 1 over 5. And square the top, square the bottom. We rationalize this one is square root of 5 over 5. So this is a solution. Not a good looking 5. So this is our solution. Okay, let's try Another one. Very similar question. We have the cosine 2 theta, and we are for sine theta. From the previous steps, we have exactly the same thing, that cosine 2 theta is given. Find the sine theta. We can use the formula we have proved here. We can list our formula. The sine theta equals positive or negative square root of 1 minus cosine 2 theta, all of them over 2. And I need to decide I should keep a positive sign or negative sign here. It all depends on where is the theta. So let's see from the given information. Theta is between 90 degrees and 180 degree. Where is it? In the second quadrant. In the second quadrant, all the theta, they are positive. So I can only keep the positive solution. All right, let's continue to plug in the information. In the square root, we have 1 minus negative 5 over 12, all divided by 2. Let's continue to simplify them. On the top, we have 1 plus 5 over 12 over 2. And on the top, we have 12. And then we have 12 plus 5 is 17. Then, so it's 17 over 12 times 1/2. We have square root of 17 over 24. Square root of the top, square root of the bottom. We are having square root of 17 over 24 equals 4 times 6. I can rescue a 2 from a square root of 24. So if you don't understand, you send me email how I get to square root of 6. And then we need to rationalize the bottom, multiply the square root of 6, top and bottom. And we are having 12. And on the top, what is that? Is 17 times, in the square root is 17 times 6 is 102. So this is a solution. All right, we're done for today. If you have any question, please let me know. Have a good one. See you.